Hello learners, we start the lecture. Okay, so this is maybe last lecture of our subject, Principle of Programming Language. In this lecture, we learn about what is the thread, semaphore, monitor, and message passing. These are some topics we cover this session. Last lecture, we understand all about what the parallel processing. In the parallel processing, we need some kind of other concept to know how these multi-programming concept we achieve through. So there are some key points we are learning through this lecture. In operating system, you all know what is operating system, which provide us an interface between user and hardware. Maybe you already using any computer system, any hardware, that machine can compute, that machine can calculate, that machine can do any other things for our purpose. But in that machine, we need an interface part, a software that may required for connecting the user. So any user, if want to work with any machine, there is required a interface that called as operating system. Operating system is having two type of interface. One is graphical user interface. Second is command line interface. Command line interface means we give instruction through the command and the machine give the output according that command. But with the help of graphical user interface, nowadays all that kind of programming, all kind of the multiprocessor programming, all kind of concept, anything we can take by the help of graphical user interface. Like we have a graphical representation of any systems. So any system, when we interact through any graphical part, like we just click on any button, click on any application, then the application is running. It's kind of the interaction in the interface of graphical user interface. If we follow any process, that is totally depend on command. So that kind of interface called as a command line interface. So in this lecture, we learn about what is the thread in programming languages, what is multi-thread, and third topic is semaphore, and last, what is the benefit of using subprograms. After this lecture, we all get the knowledge about the what is threading, what is multi-threading, what is semaphore. These the part of also processing, these the part of operating system. So in principle of programming languages, we need to learn this topic that help us to know what kind of process that are required for programming in kind of that nature that help the system also. So we need to process any program. Program is many line of instruction. So these line of instruction, when we compile that, when we run that program, whenever these processes are compiling, processing, running, so they require some kind of memory space, some kind of storage, some kind of processing, some kind of time. So these all requirement, whenever any applications that having multiple lines of programs, multiple line of code that are running at that time. So they divide these processes, these program into subprograms, and these subprograms called in programming thread. And these threading concept is useful to execute these processes in some lightweighted program. So we know about what is thread, and these thread when running, when executed in multiple times at a moment, they called as multi-thread. After these multi-thread system, whenever you process many instructions at a time, there are some problems may occur. These problems are solved by the semaphore. So all these concepts we learn through this lecture. So we start from what is the thread? So threads are lightweighted processes. It is the part of process. Like we have a Chrome browser. Whenever any developer, any programmer start to coding for making the Chrome application, so that programmer required some other programs to complete this application. So anyone when writing a program to just complete for a process, but the process having multiple options. Like we have a Chrome browser. Whenever we open this Chrome browser, we taking many tab in that these Chrome browser. We add any tab, we delete any tab, we add on other tab, we check the what is the history of this Chrome browser. So there are many options for any process, any options, any applications, any function of any application requires some kind of program, some kind of code. So these complete processes like we just click on the Chrome, but Chrome, when we click on the Chrome browser, there are multiple line of code are executing at that moment. And these multiple lines of code are divided in subprograms like threads. So we just need to complete one processes in multiple simple small programs, small processes. These small process are called as thread. So they explain what is thread. Thread are lightweight. Lightweight means this is the part of a process. Here we display a diagram. When K is a kernel thread, you need to know what is kernel. I will also explain about it. Kernel. Whenever we have any operating system, we have any kind of operating system like Linux, like Windows, like mobile operating system. So all operating system have their main concept. It called as core part of any operating system, and these core part of any operating system, any user interface called as kernel. Any time when we need to complete any instruction with the help of processor, we required a calling feature that manage the kernel thread. And these kernel thread, and there is also a second type of thread is user thread. So thread are lightweighted process that can be run concurrently. Concurrently means many lightweighted processes are completely within same program and same time. So they require some same memory. So they're sharing the memory also. So they share memory and resources. Resources means if they required any input, output related resources, related hardware, like we just complete, we start to Chrome browser. So we need to double click on the Chrome application, and these double click are followed by the keyboard or the mouse. When we don't click on that button, the Chrome application is not running. So if we just click on that button, the resource they require to click for that, when we click on that, they communicate and they open the lines of programs. These programs are saved in this your secondary memory. And secondary memory, like if we are using Windows operating system, so there is local C drive when all the required software of the operating system, the hardware, the drivers of operating system, the drivers of any hardware. So any device, whenever we connect with our computers, any device, any external device required some kind of program. That program called as driver, it need to install in our system. Then the memory and the resources are obtained. So many applications, many programs, many processes are running at a time. they required some memory. These memories are commonly used, so it's called as a shared memory, and the resources they acquired for their use. So whenever we play any game in computer system, if we have a hardware joystick, so that means the resource is joystick is totally consumed by the gaming application. There are other things also required, the variables and message passing, which means if we fight two-person, so one person saying like you come here and I will fight with you. Second person also said you come in my area, I will fight with you. But when both the fighter, both the person agree on a particular location, like we fight on that location, you came there, I will come there, we fight on that location, which means it is message passing. They just pass message, you come here, I will come here, then we compromise our situation. So these called as a shared memory. In computer languages, when some resources are commonly used by all these programs, all these process, all these jobs, all these applications, so these resources are put on the shared area. Like two-person having only one pencil at a time, but both person required that pencil at that moment, but they don't get it. It's a situation that called as a race condition. We will also learn these kind of race condition in the coming slides. So race condition whenever occur, but we need to complete one person work and second person work also, but we can't get both provide the pencil to both at that time. Then we compromise, we maintain a situation like whenever you use this pencil, just use it and also put in this area. When I require, I will get it from there. And whenever my work is complete, I will put it here. So they decide to share their resources, and the process of sharing these resources and communicate between, like with their variables, with message passing, they have some kind of anonymous like coding. They just give any gesture, any kind of their requirement, any kind of their process to complete their program in the in this multi-programming system. So all processes, like we need to use screen at the time, we require output of our program on that screen, but multiple programs are running at a moment, so they require, all these applications require output on your screen. But current application which is running at that time, that application can only present their output on the screen. But the operating system manages all kind of these scenario in the operating environment by these kind of shared memories, message passing, and many other things to maintain these collapse. So threads are often used to parallelize computation and improve performance using multi-core processor. If we have only one processor in our computer or in our machine, and that processor have multi-core requirement. Multi-core means we have a option to complete multiple operation at a moment with the help of processor core. Core means when we have multi-core, yeah, dual core, so we have a option to complete both two operation at a moment. We have multi-core, we have 1, 2, 4, 5, 8 core in our computer, in our processor. That means we can operate 8 programs at a moment. But it's not 8 process, because a process is also having multiple light-weighted process. And these process called as thread. Whenever we complete these computation, so we require parallelization. Parallelization means we put our process in multiple form, not in serial form. Okay, great. Okay. Then monitor. Monitors, just a word, it is also complete with the thread. And there are some also other mechanism like synchronization. Synchronization means whenever any resource, any program, any process requires same resources and they sync. Sync means they just put that resources to these processes. They called as a synchronization mechanism. Monitor are another synchronization mechanism used to manage concurrent access to shared resources. A monitor is the abstract data type that encapsulate a shared resources and provide method for accessing and modifying that resource. Monitor ensure that only one thread can access the resources at a time and provide a mechanism for waiting on a resource until it becomes available. I already tell you about what is the problem. If process, if program, if application required same resources at that moment. So if we provide to one, then the second process in the waiting situation for that resources. So they monitor means just look at the problem and provide solution according to that. So this is also a situation in multi-programming environment. So we need to learn what is maybe the program we compile, we run at the moment when they require same resources. So what is the solution for that? Monitor. Okay. Message passing also a conversion between these interprocess communication. So they have a mechanism for communication between processes or threads in a concurrent system. If they just notify by I can take your resources, it is communicated between these processes and thread because concurrent system are completing same kind of problem, same kind of program, same kind of instruction at that moment. They required some communication between them to complete these problems. What is the fundamentals of thread? Thread is lightweighted unit of execution that exists with a process. So it is part of the process. What is the process? Process it a instructions, a job, a application we want to run. So there is no much difference between process, job, task, instructions are same. And these processes having multiple kind of small processes that called as thread. Threads share the same memory because a process is single and one process having multiple threads. And these multiple threads sharing the same memory space to process this application. So all these threads sharing same memory space is the process they belong to and can communicate with each other by reading and writing to the shared memory. By dividing a program into multiple threads, why we need to divide this one program into multiple threads? Because it is possible to perform multiple tasks simultaneously when we just putting one program to the processor, but these program having multiple line of code and we divide the multiple line code into multiple threads, then our possibility to complete multiple tasks, multiple sub-thread, sub-programs of that task simultaneously, such as handling user input, processing data, and performing background tasks without blocking the main thread of execution. So there is no interruption. There is no fault tolerance in between these programs. If we not maintain these kind of solution, then there may be some kind of error, some kind of blocking situation, some kind of a non-completion state like we just wait one process is completing with the help of resources and the process can't free their process. Just a second. So we complete these processes with the help of multi-threading approach. So there is a diagram showing the multiple threads in one process. So this is the concept. Threads are nothing but these the process sub process part. Why we use these sub threads? Because threads execution and creation is much faster context switching between the threads. Threads can be terminated easily, faster communication between multiple threads. So threads operate faster a comparison to process because process having multiple threads, multiple subprograms. What is the application of multi-threading systems? They complete concurrent programming. Threads allow multiple tasks to be executed concurrently, improving the performance and responsiveness of an application. So, whenever you start any application, any software, they complete these single application process in multiple threads, and they complete the application because we need the fastest response of this application. Like we just click on the Chrome browser and the Chrome browser is opening in 5 minutes. No, we require the fastest response of these double clicks. Like we just click on the Chrome browser and the Chrome browser is just open after few seconds. When we approach the thread, if we don't follow the threading system, multi-threading system, the application really taking much longer time to complete that programming. Second, we also, with the help of multi-threading environment, we process and we maintain the parallel processing. Like threads can be used for parallel processing tasks such as image and video processing, scientific simulations. Last time we discussed about what is by the help of these parallel processing, we complete like many applications like AI, ML, video rendering. So many applications are completing through that. Third one is user interface. Threads can improve the responsiveness of a user interface by allowing long-running tasks to be executed in the background while the user is interact with the interface. Networking threads can be used for handling network connections and requests, such as sending and receiving data over a network socket. So, in networking, in computer networking, whenever we need to connect multiple connection, multiple computers at that time, so we follow this kind of networking with the help of multi-threading system. We also completing this process with the help of thread. Like gaming, threads can be used any application which is having much bigger, like the application is having more storage, more space requirement, more memory requirement. So they help with thread. With they divide these complete application, complete process into multiple processes that called as thread. So thread can be used in gaming application for handling graphics, rendering, physics simulation, and game logic. What is the advantage of thread? Whenever we compute, we just perform our single process into multiple small threads, then it improve responsive. Response improve means the performance automatically increase. The resource utilization, like we have multiple resource input, output, hardware, like, and we just put our process in multi-threaded system, then the resource utilization is also be better. And CPU resource also distributed very less workload and multiple threads. So there is thread can significantly enhance the performance of an application by allowing multiple tasks simultaneously. Then what is the better resource utilization? Threads can help to fully utilize the available CPU resources by distributing the workload across multiple threads. What is workload? Workload is not like we have to put these things to there, but in the programming we have multiple kind of programs, multiple lines of program, multiple lines of code. They complete through the processor, but we just contribute these single tasks into multiple small tasks, and they just put one task after, yeah, multiple tasks at that one way, and follow the multiple threads environment. They also help us, the multi-threading system also help these programming in simplified way, well structured design, making writing complex application easier. And after all, responsiveness, the threads can improve the responsiveness of the user interface by allowing for background processing of long running tasks. What is disadvantages? We just think whenever any concept may help our programming in better way, they have some also problems. Like I also said, what is the race condition when same resources are occupied by one process, and this situation is not complete in near future. This called as a race condition. And over whenever we follow this kind of race condition, we may have the deadlock situation over there. So first one is complexity. Threads introduce additionally complexity to an application. Whenever we introduce the thread, like we just write a program, but when we include these single function and multi-thread program in that single program, so it more complex, and it is harder to design, implement, and debug. Debug means we checking the error in that program. Second, race condition, if not correctly synchronized, whenever two processes require same resources and we don't synchronize these process, these state at that time, then it cause a race condition which can cause unpredictable behavior and errors. Third one is deadlocks. Deadlocks means a type of locks when we put a situation like that, when multiple threads wait for each other to release a resources, one resource is occupied by one process and it's not completed, it is not released that resources, and that situation is going into the deadlock situation. So a deadlock can occur leading to the system freeze. System freeze means the system is not responsive at all after the situation is occurred. Fourth one is resource contention. Threads can compete for shared resources such as memory, leading to the contention and potentially slowing down the system. Debugging. Debugging threaded application can be challenging due to their complexity and unpredictability. This concept is more knowledgeable, more required some more information. If we don't complete that part in very good way, then it may be complex for anyone. Then we just learn about the semaphore concept. So semaphore also related to the race condition, the deadlock. When you learn about operating system, you all also read all kind of these concept in operating system also. When two processes are not completing, they acquired same resources. So we follow some kind of new rules. Like we just put, if a room can only stand five people in that room, but whenever sixth one people entering the room, but there is a lock, there is some situation, we just put from the gate. We follow some kind of functions, like we have value of 5 in kind of function. Whenever one person is out, then the value of 5 to down to 4, and we have a option to enter one person that room. So these kind of implementation of system to avoid any situation, any problem, and these concepts are also follow in programming, and these called as a semaphore. A semaphore can be implemented as a class, okay, in object-oriented programming like C++, Java, with method for initializing the semaphore, acquiring the semaphore, and releasing the semaphore. So these are the semaphore is a class, and we put some value. When we require only 5, we can have only options to uh, complete only 5 process at that time. So we schedule only 5 process to the processor, and after that we just log the room, log the outside. to avoid any situation to freeze our system, and we release after them after 5 of process. If any process is completed, we just allowing one person to enter, not 2 person. So there is a situation, there is a initialization, there is a method for implementation to avoid these kind of problems. So we just initialize a semaphore, then we acquire semaphore, then we release the semaphore. Semaphore is a class to maintain, implement these kind of concept. The semaphore class can also include properties to store the current value of the semaphore counter. So these are already complete the theory to when we have only options to 5 process at a moment to the processor. So we put the counter, the track number, the value to complete number of threads waiting for the semaphore. A semaphore is a synchronization primitive used to control access to shared resources between multiple threads or process. Likewise, we have 5 processes for 5 threads, but whenever 6 thread is coming and they required any of resources, they are distributing, they are sharing with 5 this already said thread, but we have only one option. If any thread is releasing any resource, then we can share these resources to other one. So these overall situation are called as a semaphore. We initialize a semaphore, we acquire the value, we fix the value, how many process can complete, how many threads can complete at that moment to the processor. Then we complete these release part. One common use case for semaphore is implementing thread synchronization in multi-threaded application. For example, a semaphore can limit the number of threads that can access a critical section. Critical section. So there is a term critical section. When we put 5 total process, 5 total thread to an area for that, if any situation may occur in that area, and that area called as critical section part of this problem of code simultaneously preventing. I already discussed what is race condition. Race condition means if two process want to acquire same resources at same time, and these called as a race condition, and ensuring that only one thread can modify the said resources at that time. Similarly, a semaphore can be used to implement mutual exclusion between threads. They also give some values, some lock, some other methods. There are multiple kind of concept to avoid the kind of situation to get, to complete our program. What is the advantage of semaphore? Why we use semaphore? Semaphore we use to prevent race condition. We want to coordinate between threads. We want to flexibility for our synchronization. We want efficient work of our programming. So what is the advantage? Semaphore prevent race conditions by allowing only one thread to access shared resources at a time. Coordination between threads, semaphore can coordinate multiple threads action by controlling their access to shared resources. Flexibility, semaphore also a flexible synchronization mechanism that can be used for a wide range of synchronization tasks. Efficient, semaphore are generally more efficient than other synchronization mechanisms. So these critical section, these race condition, these multi-programming environment. So there is a very useful mechanism for synchronization. You just know what is the technical meaning of this synchronization. And when we put a before this synchronization, is also different word, different kind of mechanism following asynchronous and synchronous, like lock and condition variable. When put any lock on before and after that, what is the disadvantages when we use any kind of these methods? These methods are complex to learn, complex to apply. So what is the disadvantage? One is complexity. Second was the priority inversion. Third one is can be error prone. Semaphore can be complex to use and require careful programming to avoid deadlock and other synchronization issues. What is semaphore? Semaphore is helping us to synchronize our programming. And this also the mechanism of synchronization. Priority inversion in certain situations, semaphore can cause priority inversion, where a high priority thread is blocked by a lower priority thread that holds a semaphore. What is higher priority thread and what is lower priority thread? Threads are the part of program, part of process. If my system is having heating issue, that means heating issue kind of these fault tolerance part have higher priority to complete their task. So in between our Zoom session and other application are running in my system, but the power hitting issue having a higher priority and it's just coming in between these all application in all programming and just shut downing our system. That means whenever any thread if have higher priority and it blocked by if any lower priority thread, then it hold a semaphore. Can be error prone. Misuse of this semaphore can result in synchronization issues like deadlock, live locks, and race condition. These are problems if the semaphore is not properly maintained. We also learn. Okay, okay. Then the monitor. We already learned what is monitor. Monitor is likewise a watching situation. We are monitoring all these kind of problems in like way that monitor is a synchronization construct that provide a high level abstraction. We already read this slide. What is the advantage of one key advantage of monitor over low level synchronization primitives such as mutex and semaphore? So these are the values we are inputting in our processing part to avoid any kind of race condition. We also complete this. What is the applications of monitor? For monitor, we maintain synchronization of shared resources, trade coordination, deadlock prevention, producer consumer program. These are the application of monitor. Monitors can be used to synchronize access to the shared resources, ensuring that only one thread accesses it at a time. Okay, only one thread can access a resources. They ensure thread coordination. Monitors can be used to coordinate the action of multiple threads. They can coordinate. Deadlock prevention monitor can be used to prevent deadlock in multi-threaded program. Deadlock occurs when two or more threads are waiting on each other to release the resources. Producer consumer problem. We all know this problem. You all learn this problem in operating system in much better way. So what is producer consumer? We want many product at a moment, but consumer want many product at a time, but producer only provide some product at that moment. And we maintain these problem in a like situation. Monitor can be used to implement the producer consumer program where one or more threads produce data and other threads consume it. So one is producing and second one is consuming. Synchronization monitors provide a mechanism for synchronizing access to shared resources in multi-threaded program. Thread coordination monitors provide a way to thread to coordinate their action, which can be useful in many multi-threaded programs. Simplicity monitor are a relatively simple and easy to use synchronization construct. Encapsulation monitors encapsulate the state and behavior of the shared resources, which can make the code easier to understand and monitor. What is the disadvantage? Overheads. Monitor can introduce overhead into a program, particularly if they are using excessively and inappropriately. Complexity, deadlock, fairness. So these are the simplest way to complete our programming in better way. The last one, the last one situation that can use for the multi-threading system that called as message passing. Message passing means we when two when process having multi-thread environment and these multiple threads are coordinated in between with the inter-process communication. So message passing is a method of inter-process communication used in programming that allows different processes or thread to exchange information by sending and receiving message. So if they have inter-process communication and they complete their programming with the help of inter-process communication, that also called as a IPC call. IPC in the short form inter-process communication. It is part of the operating system. We also learn here because in multi-programming environment, we require to complete our programming in easier way and we need to synchronize our processes, our programs in that kind of way that there may be no lack of any memory spaces, lack of the time to avoid the any race conditions, like if our programming may complete run in a easier way. There are two main type of message passing. Is one is synchronous and second one is asynchronous. When they complete their problem at that moment and they conclude it at that time, they follow the synchronous. If one process is complete, then they inform to other one that called as a asynchronous. In synchronous message passing, the sending process or thread block until the message is received and processed by the receiving process or the thread. In asynchronous message passing, the sending process or thread continue execution immediately after sending after. So message and the receiving process or thread process the message later. What is the advantage of message passing? Message passing advantage is decoupling. Messaging passing decouple the sender and receiver of a message, which can make the system more flexible and maintainable. Second one is asynchronous communication. Messaging passing can enable asynchronous communication between program or thread, which can improve performance and scalability. Fault tolerance. Message passing can provide fault tolerance by enabling program or threads to continue running even if some of the component fail. Security. Messaging passing can provide security by enabling programs or threads to communicate securely over the network. So these all the advantage of the message passing. What is disadvantage? So all other applications like Semaphore, these also have a overhead situation. They have complexity, error handling, debugging. So all these part also disadvantage of message passing. Also, message passing can introduce overhead in a program, particularly if messages need to be serialized and deserialized, or if they need to be transmitted over a network. Complexity. Message passing can be more complex than other communication paradigms. Particularly, the system needs to handle different type of message or support different messaging pattern. Error handling. Message passing can introduce error handling issues, particularly if messages are lost or corrupted during transmission. So we put any message, but the message is lost, message is corrupted, then the second process, second thread not understand what kind of the message are the thread is provided. Debugging, message debugging, passing system can be more difficult than debugging other communication paradigm. So after all, we all learn what is the thread. Thread are the sub programs, sub part of any process, sub part of any program. So thread is a lightweighted program. That is also part of same process. We can also say if we have single line of instruction in thousand way, but we can complete this single line in thousand way to complete in small, like we just put one after one, one after one, one after one, that kind of wave approach to complete our problem in simple way, that called as a like thread like environment. What is multi-threading? Multi-threading means when we propose to instruction many instruction at one time to for processing part, that called as a multi-threaded. What is semaphore? We want avoid any kind of race condition in our programming. We help with semaphore, we help monitor. So any other part that help us to avoid any race condition, any fault tolerance, any inter-process communication, we require some kind of concept we learn through. And what is the use of subprograms? Subprograms means the multi-threaded, the threading system in our system. So most probably all these topics complete from my side. If you have any kind of problems, this is just theoretical concept, and there is not like practical things, but you complete by the time like C language and C lab. So there may be use of these PPL subject. All the concept we are learning through these subject, like what is method, what is class, what is variables, any kind of stories, just putting knowledge why these programming are beautiful, why we need to know how exactly we can do programming or programming space. So from my side, all these concepts are done. If you have any kind of problems, any kind of not understanding part of this lecture, yeah, other lectures, so you put your message over here in chat box. I will explain all these things. We have much time. If you have, please write in chat. From my side, I unmute you all. If you want to speak any query, please ask one by one. Okay. You can unmute from your side. The exam pattern, all about that. Person sir will share all these information through WhatsApp. So don't worry about that. Okay, we conclude the session now. Happy learning.